Let's work on factoring and simplifying rational expressions. We'll start by saying what a rational expression is. So a rational expression is in the form p of x divided by q of x. And what each of those is a polynomial or rational function. So each of these is going to be a polynomial or rational function, which means there's going to be variables in the numerator and in the denominator. In order to be a polynomial or, that should have been radical, or radical function, polynomials, remember, are like quadratics or cubics. They're really nice functions. Radicals have square roots in them. What they are not is logarithms, absolute values, or exponential functions, to name a few. So in a rational expression, we have to be concerned about the domain. The domain, just like we did when we had the graphs of rational functions, the domain is restricted when the denominator equals 0. So the domain for a rational expression is going to be all real numbers except the x values that make the denominator equal 0. So let's kind of get some instructions down on paper for how to write expressions in lowest or simplest terms. So there's a couple of ways of saying that. So to write rational expressions in lowest, or sometimes it's said simplest, sometimes it's said form, or sometimes it's said terms. So to write rational expressions in lowest terms or in lowest form, or to write rational expressions in simplest form or simplest terms, those kind of all mean the same thing. So the steps to doing that are going to be, first, you will factor the numerator and denominator. So that might include the GCF, difference of squares, AC method. Second, we are going to write the restrictions or excluded values on the domain. And we do that by setting the denominator not equal to 0. Then we will divide out common factors. Sometimes we call that canceling legally. But really what we're doing is dividing common factors. So let's kind of look at some examples of what cancels, because we make lots of mistakes usually when we're working with canceling legally. It gets a little bit overwhelming about what can cancel. So here's some examples. And I want to know what cancels. There's 4 different problems here. So 2x over x. When we see 2x over x, we can think of it like it's 2 times x over x. And once we see it written that way, we can tell that the x and the x exactly match. So we can cancel the x's, and that will just leave us with 2. So that would cancel the x's. Let's look at 2x plus 1 over x. If we break this down into multiplication, that's just 2 times x plus 1 divided by x. Now this addition is like super glue. Like we cannot cancel off the plus 1. It is stuck to the 2x like none other. So we can't cancel off anything as long as there's addition going on, if it's not in parentheses being multiplied by something else. So I cannot cancel anything in this problem. So nothing cancels. X minus 2 over 2. Again, subtraction is also like super glue, like addition. That x and that minus 2 cannot be separated. So I cannot cancel the 2 and the 2. So in this one, nothing cancels. How about x minus 2 over 2x minus 4? Well, I can rewrite 2x minus 4 by taking a GCF out. So it would be 2 times x minus 2. Now I can see that I have x minus 2 in the numerator that's really times an invisible 1, and 2 over x minus 2 in the denominator. So the x minus 2's cancel, and that's going to leave me with 1/2. So kind of think of it like this. This multiplication is like Velcro. Like we can separate it if you have, you know, the fuzzy side and the pokey side. So you can separate it if you have a matching pair. But addition and subtraction is more like super glue. And those terms cannot be separated. So we can't cancel if we have addition subtraction, but if we have multiplication, we can. And you'll see plenty more examples of what cancels as we go through the next examples. Okay. Another thing we've got to be careful with when we're doing these is negatives. So I'm going to show you how to cope with things when they look the same but they're not quite because of their signs. So we're going to say be careful with negatives. So we're real tempted when we see something like y minus 3 over 3 minus y. We're super tempted to say that that cancels because you have a y, you have a 3, and you have subtraction. But they're not exactly the same. So what we're going to do when we see something like this is factor out a negative 1. And it doesn't really matter which one you factor it out of. We're just going to take a negative 1 out of something. So if I take out a negative 1 in the numerator, that will leave me with negative y plus 3, and it's over 3 minus y. Well, remember the commutative property of addition says that I can rewrite that as negative 1 times 3 plus negative y, or 3 minus y, over 3 minus y. Well, now I have a matching pair. I have negative 1 times 3 minus y over really 1 times 3 minus y. So 3 minus y's cancel, and I'm just going to be left with negative 1. Let's look at some more negative issues. So I want to know which one or ones are the same as x minus 3 over 4 minus x. So I'm going to give you 4 choices. 3 minus x over x minus 4. Negative 3 minus x over 4 minus x. X plus 3 over 4 plus x. And negative x minus 3 over x minus 4. Okay, well let's look at the let's look at letter A. So I want to see if I can make 3 minus x turn into x minus 3. Well, I can do that if I factor out a -1. So that'll be -1 times -3 plus x. And I want to make x minus 4 match 4 minus x. So if I take out a -1, that will be -x plus 4. Well, I see that those -1s can cancel. So that's going to leave me with -3 plus x, which is the same as x minus 3, over -x plus 4, which is the same as 4 minus x. So A is the same. Okay, let's move on to B. Is B the same? Well, when you see a negative out in front of a fraction, what you have to remember is that negative can either go to the numerator or to the denominator, but it cannot go to both. So since my denominators already match, I'm going to make my negative distribute into my numerator. So that's like taking a -1 times everything in the numerator. So -1 times 3 is -3. -1 times -x is plus x. And then the denominator doesn't change. So I have -3 plus x over 4 minus x. -3 plus x is the same as x minus 3, and 4 minus x is obviously the same as 4 minus x. So this one is also the same. Letter C, x plus 3 over 4 plus x. Well, if I try my -1 trick, I factor out a -1, that's going to leave me with -x minus 3. If I factor out a -1 from the denominator, that's going to leave me with -4 minus x. If I then cancel out my -1s, I'm left with -x minus 3 over -4 minus x. And that does not match the numerator, and it doesn't match the denominator, so this one is not the same. And then letter D. Letter D looks similar to letter B, but this time I'm going to let my negative sign distribute to my denominator because the numerators already match. So I'll keep my numerator the same, x minus 3, and do -1 times x gives me -x. -1 times -4 is plus 4. 4 minus x is the same as -x plus 4. So letter D is also the same. So 3 of these were the same and only 1 was different. Now that we've worked a little bit with negatives, let's do some examples of simplifying the expression and listing the restrictions on the denominator. Simplify the expression. List restrictions on the domain. So altogether we are going to have 8 of these problems. So here's our first one. X plus 2 over x squared plus 2x. You might want to flip back and forth between your instructions that we had on the previous page and your problem. So I'll just put those here for a moment. The first thing we're going to do is factor the numerator and denominator. Then we write the restrictions or excluded values by setting the denominator not equal to 0. And then we will cancel legally. So that's what we're about to do. First thing we've got to do is factor. The numerator doesn't have any GCF or any squared values, so it just stays x plus 2. The denominator has a GCF of x, so I'll take x out to the front, and that leaves me with x plus 2 in the parentheses. Now before I do anything else, I'm going to get my restrictions. And I do that by setting the denominator not equal to 0. So I do x times x plus 2 cannot equal 0. And then I'm going to set each part that contains a variable not equal to 0. So I take the x and set it not equal to 0. I take the x plus 2, set it not equal to 0. And then that's going to give me two numbers. It gives me x cannot equal 0 from the first one. And then when I subtract the 2 over, it gives me x cannot equal -2. So here's a part of my answer. X cannot equal 0, x cannot equal -2. And then next I look to see what can cancel. Well, I can cancel anything that matches exactly. So if you think of this x plus 2 as though it were 1 times x plus 2, now I have Velcro and I could cancel x plus 2 with x plus 2, and it's going to leave me 1 over x for my simplified form. Number 2. X squared times x plus 1 over x times x plus 1. So in my steps, the first thing I'm supposed to do is factor. But I'm telling you, this is mostly already factored. The only one thing that we could do would be to break down this x squared and rewrite it as x times x plus 1, and then have it over x times x plus 1. Then we'll list our restrictions. And we do that by setting the denominator not equal to 0. So x times x plus 1 cannot equal 0. Well, that's almost just like our other one. So remember, we set x not equal to 0, so x cannot equal 0. And we set x plus 1 cannot equal 0. Subtract the 1 over, so x cannot equal -1. So there's two restricted values. And then we start canceling. I can cancel things that are multiplied as long as they match exactly. So I've got an x plus 1 that can cancel with an x plus 1. And then I have an x here that can cancel with an x here, which is going to leave me with a single x in the numerator. So it would be like x over 1, but we don't usually write the over 1, so it will just be x. Number 3, x plus 5 times x minus 3 over x minus 5 times x minus 3. What is the first step? The first step is to factor, but that is already done. It's already as factored as it's going to get. So after the factoring step, what comes next? The restrictions. So I take my denominator, set each part that contains a variable equal to 0, not equal to 0. So I have x minus 5 cannot equal 0, and x minus 3 cannot equal 0, which gives me that x cannot equal, add the 5 over, so x cannot equal 5, add the 3 over, and x cannot equal 3. Next up, we are going to cancel. So we can only cancel things that are multiplied and only if they match exactly. Well, these two parentheses sitting next to each other means multiply. So I have an x minus 3 that can cancel with an x minus 3, and I have x plus 5 over x minus 5. So remember that the addition and subtraction is like super glue, so I cannot cancel this x with this x, nor can I cancel this 5 with this 5, because it's x plus 5, which is different from x minus 5. So once I do my canceling, I'm going to be left with x plus 5 over x minus 5, and nothing else will simplify, so that's going to be my answer. Example number 4. We have 3x plus 7 over 3. So let's think about our first step of factoring. There's no GCF. There's nothing that's squared. So really the only way I could really think about this differently would be 3 times x plus 7 divided by 3. but this 3 times x is being added to the 7, so it's like super glued together. So the 3's can't even cancel. So nothing factors, and nothing cancels. And let's talk about the restrictions. Restrictions come from setting the denominator not equal to 0. Well, what's in my denominator? It's a 3. 3 cannot equal 0. Well, duh, 3 cannot equal 0. So what you need to know is that if there are no variables in the denominator, then there will be no restrictions. So 3 cannot equal 0 doesn't even make sense. We ignore it. If there's no variables in the denominator, there are no restrictions. We've already said nothing cancels, nothing factors, so the answer to this question is just 3x plus 7 over 3 because nothing else can be done. Okay, we've got 4 examples down, 4 examples to go. Six m plus 8 over 7m plus 21. Okay, first step is to factor. I see that I have a GCF in the numerator of 2, so I can take a 2 out, and I'll be left with 3m plus 4. In the denominator, I have a GCF of 7. Oh, I copied the problem down wrong. That should be 6m plus 18, which gives me a GCF of 6 and leaves me with m plus 3. Well, that was silly. And then in the denominator, I have a GCF of 7, which leaves me with m plus 3. Now, before you get all excited about canceling, remember that the next step is restrictions. And we do that by setting the denominator not equal to 0, and that tells us that m cannot equal negative 3. This GCF of 7, we don't set that not equal to 0 because it does not have a variable. And if there's no variable, it doesn't give us a restriction. Only the m plus 3 gives us a restriction. So m cannot equal negative 3 is our restriction. And then we're going to cancel. So we have 6 times m plus 3 over 7 times m plus 3. So our m plus 3's cancel. And we're left with 6/7 for our simplified expression. Number 6, x squared minus 4 over 2 minus x. Our first step is to factor. And it looks like the numerator is going to be difference of squares. So in difference of squares, remember we unsquare the first, unsquare the last, and it makes x plus 2 times x minus 2. And then we have over 2 minus x. Now that we've factored, let's get our restrictions by setting the denominator 2 minus x not equal to 0. This time I think I'll add the x over, and that gives me x cannot equal 2. It's the only restriction I have. And then we'll get on to the business of canceling. Now, I've got x plus 2 and x minus 2 in the numerator and 2 minus x in the denominator. So remember when we had that before, if it's off by all of the signs, so when we cancel, if the signs are off, we are going to try factoring out a negative 1. So I'm going to try factoring a negative 1 out of this guy right here. So I'm going to keep my x plus 2 the same, and I'm going to take a negative 1 out in front of this parenthesis. So when I do x divided by negative 1, that leaves me negative x. Negative 2 divided by negative 1 leaves me plus 2. And then the denominator is 2 minus x. Now, can I cancel that? Yes, I can, because this is as though it's in a parenthesis times 1. And remember that 2 minus x is the same as negative x plus 2, so those guys cancel. And in the numerator, I would have x plus 2 times negative 1. And in the denominator, I have 1, which we've said a minute ago we don't usually write. So then I could rewrite this by distributing the negative 1 back in as negative x minus 2. All right, let's try a couple problems where we really get to factor. Okay, so our first step is going to be to factor. This one's going to take us a bit more time because we have two AC methods. So remember, in the AC method, we take the first term times the last term. So we're looking at negative 14y squared. And we want the combination that is going to add to give you the middle term, which is negative 5y. So you might need to list out a couple, so like y and 14y, or 2y and 7y. Now remember, to multiply to give you a negative number, these signs are going to have to be opposite. And I need to add to get negative 5y. So it looks like I will need a positive 2y and a negative 7y. So I'll rewrite my y squared minus 5y minus 14. I rewrite that as y squared plus 2y minus 7y minus 14. Then group those. Take out a GCF from my first group, and it'll be y times y plus 2. And then in my second group, I have to match y plus 2. So what am I going to need to divide out of negative 7y minus 14 to match y plus 2? And that is a negative 7. I take out my common group, and then my GCFs for my other parenthesis. So the numerator there is going to factor to give me y plus 2 times y minus 7. In the denominator, I need to look for the pair that multiplies to negative 2y squared but adds to positive y. So that will be y times 2y. And in order to get positive 2y when I add them, I need a positive 2y here and a negative y. So I'll rewrite that as y squared minus y plus 2y minus 2. Out of my first group, I take a y, which leaves me y minus 1. In my second group, I need to match y minus 1. So I'll need to take out a positive 2. So my common parenthesis will be y minus 1, and my GCFs leave me y plus 2. Okay, I know at this point it's really tempting to go ahead and cancel, but we have to first do our restrictions. And we do that by setting the denominator not equal to 0, each part that has a variable. So I set y minus 1 cannot equal 0, and y plus 2 cannot equal 0, which is going to give me that y cannot equal positive 1 and y cannot equal negative 2. Once that's out of the way, you can go ahead and cancel your face off. I have y plus 2 times y minus 7, y minus 1 times y plus 2. So the y plus 2's cancel, and that's going to leave me with y minus 7 over y minus 1. Nothing else cancels because those are superglued. Look at that, we're already on lucky number 8. 6x squared minus x minus 2 over 3x squared plus 13x minus 10. This one looks like it's going to be a doozy to factor. So we'll start off by taking the first times the last. So I've got negative 12x squared. I need the pair that multiplies to negative 12x squared but adds to negative x. So I could have x 12x, 2x and 6x, 3x and 4x. They need to multiply to negative 12x squared, which means one needs to be plus, one needs to be minus. Add to negative x. So if I have plus 3x minus 4x, looks like that's going to work. So I'm going to rewrite my problem. 6x squared plus 3x minus 4x minus 2. Take out a GCF from this first group, which will be 3x, which leaves me 2x plus 1. And then in my second group, I've got to match 2x plus 1. So I'm going to need to divide out a negative 2. So that numerator, I'm going to work over here, that numerator is going to factor to 2x plus 1 for my common parenthesis times 3x minus 2 for my GCFs. Okay, let's factor the denominator. I take the first times the last, so that's negative 30x squared. So I need a pair that multiplies to negative 30x squared but adds to positive 13x. So in order to multiply to a negative number, one has to be plus, one has to be minus. We got to keep that in mind. So I could have x and 30x, 2x and 15x, 3x and 10x, let's see, 5x and 6x. I think that's all of them. So I need the pair that is going to add to give me 13x with one positive, one negative. That's going to be these guys here, 2x and 15x. 15 needs to be the plus to get me the positive number, and 2x needs to be the negative. So we rewrite as 3x squared, 3x squared minus 2x plus 15x minus 10. And then look at my group. What can come out of that first group? Only an x, which leaves me 3x minus 2. And the second group needs to match 3x minus 2. So what can I take out to make it match? Plus 5. So my denominator factors into 3x minus 2 for the common parenthesis times x plus 5 from the GCFs. Again, don't get too excited to cancel until you do your restrictions. So we set the 3x minus 2, because it has a variable in the denominator, not equal to 0. We set the x plus 5 not equal to 0. And then add 2 over, so 3x cannot equal 2. Divide both sides by 3. So x cannot equal 2/3. And subtract 5 on both sides here, and x cannot equal negative 5. So there's my restrictions. And then I can go ahead and cancel. 3x minus 2 matches 3x minus 2. So I'm going to be left with 2x plus 1 over x plus 5.